Welcome to Zoom In, Zoom Out, your global look at news from Taiwan. I'm Reece Ayers. Humanity's search for extraterrestrial life will take a big step in October when NASA plans to launch an interplanetary probe. The $5 billion spacecraft, named the Clipper, will begin a 5-year journey to Jupiter's orbit, where it will study the planet's most famous moon, Europa, considered by scientists as one of the best candidates in our solar system for hosting life. To further discuss moons, exoplanets, and everything astronomy, we're joined today by Alex Teachey. Alex is a postdoctoral fellow at the Institute of Astronomy and Astrophysics at Taiwan's National Research Academy, Academia Sinica. Hello, Alex. Thanks for joining us.
Thank you so much for having me, Reece. Good to be here.
Well, we saw the news about the NASA spacecraft. Is this what astronomy is about? What do most astronomers do?
You know, astronomers, most of what we do is study the sky from, down here, either ground-based telescopes or space-based telescopes. NASA, with this Europa Clipper that you've just mentioned, now in the last 60 years or so, we're able to send spacecraft to the planets and the other stars, and that becomes kind of more of a planetary science domain, right? So as astronomers, we're using telescopes to study everything beyond the Earth. That could be the planets, could be moons, asteroids, comets, our own sun, of course, other stars in the Milky Way galaxy, the planets around those stars, the gas and dust between the stars, the other galaxies out there beyond our own Milky Way, the structure of the universe itself. Really everything out there is the domain of astronomers. So there's a lot to do. The universe is a very big place, obviously. I often get asked when am I going to go to space, because astronomer and astronaut, people get these sort of confused. I'm not an astronaut, I'm an astronomer, and so I'll never be going to space, but that's just fine with me because it's kind of hazardous work.
So I know that you focus on exoplanets and exomoons. Europa would be described as an exomoon?
That's just a regular moon. Yeah, so exoplanet is a planet around another star outside of our solar system, and then the exomoons are the moons of exoplanets. So in this case, Europa is a moon of Jupiter in our own solar system. So just a regular old moon, but as you rightly pointed out, a particularly fascinating one for a lot of reasons.
So tell us a bit more then about exoplanets and exomoons. What's the value in studying things that are so far away?
I think it bears directly on questions of life, say. We're interested in finding life out there. These planets, some of them are going to be good places to look for life, but also when we understand more our own context in the Milky Way galaxy, can we start to unravel how common is life out there? How easy is it going to be to find out there? Because most astronomers, I think, would say, yeah, just by sheer numbers, it's very likely that there's life out there somewhere, right? We've got hundreds of billions of stars in the Milky Way galaxy. We've got hundreds of billions, if not trillions, of other galaxies out there. So life must be out there. It's not guaranteed. It's not 100%. It might be 99.99999%, something like that. It's a good bet, in other words. But how abundant is it? How easy will it be to find? Could be microbial life out there. Could be macroscopic life, maybe even intelligent life. This is obviously very much an open question. And for me, anyway, I think that is a particularly powerful motivator.
And so Europa is a word that you come across a lot in the media whenever there are stories about space exploration. So is there a kind of general feeling of excitement about this new venture to Europa and that it could potentially actually reveal that there's maybe life?
Yeah, absolutely. Europa, for decades now, we've known as a very exciting world because it's covered in ice, but underneath that ice is a global ocean of liquid water. And so when we're thinking about where to look for life, the top thing on our list is look for the liquid water, right? It's essential for life on Earth. It's a good bet that it's going to be essential for life elsewhere. So we want to take a closer look. We've been imaging Europa over the years, but this particular mission is going to be the first one that is devoted specifically to looking at Europa. It's going to fly by again and again and again, image the surface close up. And one of the really cool things about Europa that's just been discovered in the last few years is that there are these what we call cryovolcanoes, sort of these geysers of material from the ocean spewing out. So that ice shell that I mentioned is maybe 10 kilometers thick or so. So how are you going to get down into that ocean? You can't drill down there. And maybe it would not even be ethical to drill into it, at least in the short term, unless we really know what we're doing. But with these geysers of material spewing water out into space, we can take a closer look at that material and say, what's in it exactly? Does it have the ingredients for life? maybe even see evidence of life directly. I'm not sure Europa Clipper will be able to answer all of these questions, but it's an important step forward in investigating what I think most people would agree is one of the most fascinating worlds in the solar system.
Well, what are the practical applications of this? Let's say, for example, we were able to find some life on another planet. It's a very exciting thing and something you see in sci-fi movies all the time. But how is that going to impact ordinary people?
I do think that whatever we find out there will be, as I said, could be astonishingly different from what we have here. But also we might see some convergent evolution, right? So here on the Earth, for example, bats and birds and insects have all independently invented wings, right? Because it's the best way to fly. And so when we look at life on other planets, we might see these same sort of convergent evolutionary processes. So, what the biologists are going to learn, I'll leave that to the biologists. But I think more profoundly, suddenly it changes our calculation entirely in terms of how abundant we think life is out there. How easy is it to make? The raw materials that we have on Earth is a very special place, but the raw materials that we need are quite common, right? Water is everywhere. And so, we have this sort of inclination, or we have this sense that life is easy to start, but we really don't know. Suddenly, if we find life, not just in another planetary system, but here in our own solar system, now we have two different worlds in just this one star system that has life. I think that changes dramatically our estimates for how abundant life must be out there.
So Alex, let's zoom in now and bring things back down to Earth. You've been living and working in Taiwan for just over 3 years.
That's right.
Does Taiwan's particular geography and topography make it a suitable place from which to watch the skies?
Well, when you're thinking about building telescopes, you kind of have a couple of considerations in mind. You want to have good weather. And ideally, you want to place this telescope as high above the atmosphere as you can. The atmosphere introduces turbulence that messes with your observations. So we have the mountains, of course. Taipei weather is not always the best, but in other parts of the country is much sunnier, obviously. There is one observatory that I know of up. It's called the Lulin Observatory. It's run by National Central University. It's at an altitude of something like 2,800 meters. Just a 1 meter telescope, which is pretty sizable. But these days, for the real top-rate telescopes, we put them in a couple of particular places around the world. For example, in the top of Mauna Kea, on the big island of Hawaii, or in the Atacama Desert in Chile, is where they have the ALMA telescope that Taiwan is a consortium member of ALMA. And so that's where we, these days, we'll put the big telescopes in these really special places on Earth. And then also in space, we have space telescopes, of course. So, as far as the amateur astronomer wanting to take a look around at the sky, just go find some dark skies and hopefully, wish it clear skies. Go down to Kenting or something like that. I saw some fabulous stars in Kenting.
Speaking of dark skies, Taiwan quite recently has designated a few parts of the country as light pollution free zones, so as to create a better environment for people who are looking to stargaze. And it's not just Taiwan, I think it's a mission that's taking place in several spots around the world. Could you tell us more about those light pollution free zones and how they impact research?
Well, yeah, so light pollution free zones are fabulous, obviously, for, you think about something like the hiking trails that are all over Taiwan. What value does Taiwan get out of building those things? Well, it's just good for the humans living here, right? Taiwan, I think, is replete with examples of things that are just good for humans. It's just good for us to be able to find places to see the night sky. My understanding is also sometimes it's good for animals, right? The sea turtles, my understanding is sometimes they're navigating by the sky. And then there's a question of just more generally mitigating light pollution. It's fairly straightforward to design light fixtures that are not wasting light by shining up, right? We want to illuminate the ground. We don't need to illuminate the sky. In fact, that's just wasted energy, right? You could redirect that light downward. I think it makes good sense to try to mitigate this thing and save energy in the process, so it has economical benefits as well.
When I think about space research and the space race, my mind goes mostly to the States, maybe to Russia, to Canada, these places that have big open expanses with huge telescopes. Taiwan's relatively small. What are Taiwan's contributions to the international field of astronomy? If you could give any specific examples.
Taiwan, I think it's made news quite a bit. Taiwan has been involved with what's called the Event Horizon Telescope. This is the global effort, or a consortium of nations, of which Taiwan is a part, to image the supermassive black hole at the center of our Milky Way galaxy. It's called Sagittarius A star, as well as the supermassive black hole in a nearby galaxy called M87. That's world news, and it's super exciting. We've made those images, but it's an ongoing project. They're still working on it. And one thing that Academia Sinica in particular is leading on right now is the development of this telescope called the Greenland Telescope. They built a telescope in Greenland. It's a very hostile place. I mean, there's telescopes at Antarctica, but short of that, this is one of the most challenging places that you could imagine to build a telescope. They built it at a research base right there, and then eventually they're going to carry it way up to the top of the summit of a mountain right in the center of the country. Very, very hostile place to work. And Academia Sinica is leading on that one. The amazing thing about these Event Horizon Telescope is that you can use these telescopes positioned all around the world, and effectively you are making a telescope that is, in essence, the size of the entire Earth. And what that does is that gives you incredibly high resolution when you're imaging things on the sky. And the Greenland Telescope is in a very special place with respect to all these other telescopes.
And so finally, we're just off the back of a total solar eclipse that happened mostly across the States. I was looking on quite enviously because I would love to be able to see something, to see totality. What do you think it is about eclipses and astronomical events that really appeals to people? With the recent eclipse in the States, I saw interviews with people who were saying they got very emotional, they were crying, and they felt really this connection to nature and at one with the world. What do you think it is about these events that people really resonate with?
Yes, that is it's a challenging question to answer, actually. I think it's sort of intangible, but it is a sort of a quasi-religious experience that I think a lot of astronomers and a lot of non-astronomers alike have experienced, particularly when you look up in the night sky, not just for solar eclipses, but anything happening, even just seeing a really, really dark sky. I remember distinctly being at my grandparents' house several years ago, and the sky was so dark that all of a sudden you had this sense of three-dimensionality, that all of a sudden I could see the Milky Way galaxy, and the bright stars were bright because they were near, and the dimmer stars were dim because they were farther away, and you could feel that you were part of this, huge, just unimaginably large universe, and you're just some tiny little part of it. And some people I know that really terrifies. Some people find that to be a very scary thought, that they are so small in this vastness, this unimaginable vastness. But in another way, it's quite humbling that you are just one part of this, incredibly grand time and space, and you are so lucky to be here in this moment and to see the things that you're able to see, to experience these things. And solar eclipses are about as special as it gets.
Beautifully said. Yeah, I feel that humbleness every time I think I look at the stars and I see. It makes you feel tiny, but in a very humbling way. You're right. That's the word, humble. Well, thank you ever so much for joining us, Alex.
My pleasure. Thank you so much.
Thank you for watching. This has been Zoom In, Zoom Out. For more stories from TaiwanPlus, you can follow us on social media. Thanks for watching, and we'll see you next time.
For more stories from Taiwan and around the world, please visit us at TaiwanPlus.com.